Hello, good evening. Let's wait for the people. Let me just check my mic. Hello. Yes. Today's topic is irrational numbers, and we're going to see what all things are involved in irrational numbers. It's probably the last topic of real numbers, and we are going to talk about what are irrational numbers and what are the properties related to it. We write the topic name, irrational numbers. Let's wait for 2 minutes. Let's see how 2 people are joined. Fine, then let's continue. So welcome to today's lecture, and if you haven't subscribed our channel, please subscribe and press the bell icon to never miss an update from us. Myself, Keshava in Tenica, and I've done MSc in Engineering Mathematics, and I'm teaching since 10 years now. Hello, hi Prachi, hi Abhishek. So we are talking about irrational numbers today. And you can also log into our website, www.letstute.com, for a wide range of different courses on maths and science. So let me just talk about irrational numbers. As we already discussed in previous videos, that what are different numbers. This is the real number line, and suppose if I'm considering some numbers on this number line. Say this is 1, 2, 3, etc. -1, -2, -3, -4, etc. So we have already seen that these numbers, which we use to count naturally, right? Generally, whenever we count anything, we start from 1 and we move on further. So those numbers are called as natural numbers. Natural numbers. So natural numbers starts from 1, 2, 3, and it goes on. And when we include 0, it becomes whole numbers. Whole numbers. Correct? So let me write whole numbers will start from 0 and go on further. Okay. And when we include even negative numbers, then these numbers are called as integers. Integers. Because they start from somewhere and it continuously go on to some other way, okay, the other extreme. So they are called as integers. They are never ending, where whole numbers start from 0. We don't know integer starts from where and goes till where. Similarly, natural numbers start from 1 and we don't know where it goes, okay. It continuously, as far as you can write, you can get those numbers. And what about the other numbers which are in between these integers? You cannot even count them, correct? Like suppose if I zoom in between 0 and 1. I can get, generally we say, okay, there are numbers like 0.1, 0.2, ... 0.9, and then we get 1. But what about if you zoom in further? Say from 0 to 0.1, we'll have 0.01, 0.02, and it will come on to 0.09, and finally we get 0.1. If you further zoom in and we talk about 0 and 0.01, the numbers between them, it will be 0.001, 0.002. So in that way, you can continuously go on writing numbers. So you cannot even count the numbers between 0 and 1 as well. Okay, so you forget about counting all other numbers. So there are so many numbers packed in between these integers. Fine, which are those numbers? We'll talk about that. So there are rational numbers. Rational numbers. What are rational numbers? Rational numbers is a ratio of two integers. Suppose p and q are integers, then whatever value we get out of p, out of dividing p by q, we say it is a rational number. It's basically a ratio, correct? Rational numbers. Ratio of two integers where q is not 0. Okay, so this is the condition. Now, what are those rational numbers? Again, let me draw a number line. Okay, now 0, 1, 2. Okay, so these are the integers. Is 0 is a rational number? Can we write 0 in the form of p by q, where p and q are integers? If we can write in that way, then we can say that 0 is a rational number. But the question is, can we write in that way? Is it possible? Yes, it is possible. How can we write 0? We can write 0 by any number. You can write 1, you can write 2, you can write 3, right? Let me take 1. You can write any number in the denominator of 0, but we are satisfying with 1. So we are getting 0 by 1 as 0, where 0 is integer, 1 is integer. So basically I can write 0 in the form of p by q. Similarly, I can write even 1 as in the form of p and q. 1 also can be written as 1 by 1, 2 by 2, 3 by 3, correct? There are many forms. So what do we understand is even integers are rational numbers. But rational numbers also include the numbers between integers, the numbers which are packed between integers. Like suppose if I take middle number of 0 and 1, so we call it as 0.5, which can also be written as 1 by 2, correct? Where 1 is an integer, 2 is an integer. So therefore it is in the form of p by q, where q is non-zero. So denominator is non-zero. So I can say that 0.5 is in the form of p by q, where p and q are integers. So therefore we say that even 0.5 is a rational number. Similarly, if we take some other number, suppose if I want to take 1.6666 never ending, okay, can we write in the form of ratio of two integers? The question is to check if we can write in this way. Fine. So suppose if I take 5 by 3, isn't it 1.6666? It goes on, right? We can check it. If we divide 5 by 3, 3 ones are 3, we are left with 2. So because of dot or decimal, we get 0, 20, 3 6 are 18. Again, we have 2, and because of decimal, we have 0. So like that, we can go on writing. That means the decimal numbers, which are never ending, can also be a rational number. Okay, but only thing is we should be able to write in the form of p by q, where p and q are integers and q is non-zero. So where you can see that I can write this number in the form of ratio of integers, then we can say that even this is a rational number. Okay, but there are numbers which are never ending and non-repeating. If you see, the numbers are repeating over here. So there is a particular significance of these repeating numbers. When numbers are repeating but infinitely repeating, that number is called as rational number. So basically, integers are rational number, decimals are also rational numbers which are repeating. Okay, what about 0.5? That's what we have talked over here. Even this is decimal number, but it is like what do you say? It is never ending and it is ending, right? And it is repeating. We cannot say it is repeating, but it is ending, correct? So therefore, what we can say is rational numbers specifically, I'm writing from here, okay? Specifically, they are like even if they're in decimal, if in decimal form, the digits are repeating. Digits are repeated, okay? Or and or we can say all digits are terminating. So basically, if I say digits are terminating, that means you don't have any more digits coming after a certain point. Like in this case, it is never ending, but non-terminating. Here, it is terminating. When these conditions are not satisfied, those numbers are called as irrational numbers. Let me write here, irrational numbers. Irrational numbers, like the numbers which cannot be written as, which can't be written, written in the form of which can't be written in the form of p by q. So basically, when the number can be written in the form of p by q, we say that it is a rational number. When we cannot write, we can say that it is irrational number. But is there a way to recognize that if the number is irrational? Yes, definitely. There is a way to recognize. What are the ways? Number one, the decimal digits are never ending or never terminating and never repeating. So those numbers are called as irrational numbers. So now today we are going to talk about these numbers. There are many such numbers, right? Like for example, root 2, root 3, root 5. There are many such numbers. Not only in roots, we have e, we have pi. So all those numbers are irrational numbers because their values are if you put it in the decimal form, they are never terminating and not repeating. Like, let me give you a fact. Generally, I've seen many times people write pi value as 22 by 7. This itself is contradicting because 22 by 7 is a rational number. Why? Because 22 is an integer and 7 is an integer, and ratio of two integers are always rational. Correct? This is rational. But on the other hand, pi is irrational. Correct? How is possible that one rational number is equals to one irrational number? That's absolutely not possible. But still, I've seen that we are using value of pi as 22 by 7. That is because pi value is 3.14 something. It looks like that. And even when you divide 22 by 7, even in that case, you get 3.14 something. But the difference is for few digits, they are same. To get approximate value, we use value of pi as 22 by 7. But many times we started believing in that value of pi is 22 by 7, but that's not the case. Okay. So there are many such numbers which you can categorize it as irrational numbers. Now there are some properties we are going to learn about irrational numbers. Like suppose if you're asked to prove root 2 is an irrational number. How would you prove? Root 2 is irrational number. How can you prove this? Hello, Dipali. And yeah, does decimals come into it? Abhishek, are you asking about which number? Is there any specific category you're talking about? Hope you're clear. Okay, if you have any doubt, please you can post it here. I'll definitely talk about it. Okay, let's talk about root 2 is irrational. So how to prove this? Is there a particular way to prove this, that root 2 is an irrational number? There is a contradiction method. In mathematics, we in many times we use contradiction method. That means we assume something to be true, and when we prove that this is not possible in our case, so we say that it is not happening. So therefore, it is, suppose in this case, if we are trying to prove that root 2 is an irrational number, we are going to assume that root 2 is a rational, and we'll try to solve according to this condition. And at one point, we'll come to know that it is not possible at all. So when it is not possible, that means root 2 is a rational number, is not possible. In that way, we have only one option, that root 2 is an irrational number. So that's how we try to prove this. So when it is irrational number, we can assume that root 2 be ratio of two integers, correct? Because rational number says so, that every rational number can be represented by a ratio of two numbers. Suppose I'm able to write root 2 as r by s, where s is non-zero value, correct? Maybe I can also write this as, suppose r equals to root 2 into s, correct? Squaring on both sides, what do we get? We get r squared equals to 2 into s squared, correct? Now, what do we understand from this? Let me give you a small revision, that I'm again telling you that root 2 is irrational number. This is what we are trying to prove, but we are assuming the contradiction thing. Like we are assuming a statement to be like this: root 2 is a rational number. So we are assuming this and trying to solve. And at one point, we'll see that what we have assumed is wrong, is not correct. So we are assuming that root 2 is rational. When it is assumed to be rational, then it has to be a ratio of two integers, correct? Where r and s are integers. Fine. So when we can say that it is rational and we can write it in this form, we can also write it in this form. What did I do? I just cross multiplied s. Okay. So therefore, squaring on both sides, we get r squared equals to 2s squared. Now, in this case, what do we understand? We understand that 2 divides is r squared, correct? From this, what do we understand? 2 divides r squared. How do we say so? Because 2 is a factor of r squared, correct? R squared is represented by 2 and s squared. So that shows 2 is a factor of r squared, correct? When 2 divides, that means 2 divides r squared. And that means 2 divides r, correct? When 2 divides r, then 2 is a factor of r. That means r can be written as 2 into p, correct? Because 2 is a factor of r squared, so 2 divides r squared. So that means 2 divides r. That means 2 is factor of r. So from this, what do we understand? What do we understand? That if we see this, we understand, if we try to put this value in place of here, in place of r, what do we get? So let's suppose we are considering r squared equals to 2s squared as equation 1. So let us try to put this in 1. What do we get? We will get 2p squared equals to 2s squared, correct? This is what we are going to get. So this gives us 2 squared, that is 4 p squared equals to 2s squared. Correct? S squared, I opened the bracket, so I got squared. Now from this, what we are getting? We are getting s squared equals to 2p squared on cancelling this 2. So what do we understand from this? We understand that s is having 2 as factor. That means 2 is a factor of s squared. So s squared, correct? Because s squared is represented as the product of 2 and p squared. So from that we can say that 2 is a factor of s squared. So that means 2 divides s squared. 2 divides s squared, and that means 2 divides s. Now what do we understand from this statement and this statement? That 2 divides r as well as 2 divides s. I'll just give them some I denote it by star. So I'm denoting this by single star, this by double star. Now from star and double star, what do we understand? From star and double star, what do you understand? 2 is dividing s and r both. So it is dividing s and r both. So what do we understand from this? That s by r are having common factors, correct? Because we are already assuming here that from the statement what we have got from here, what we can say that 2 is a common factor. Common factor. But what is the definition of a representation? If you see here, we have represented root 2 as r by s, correct? What is the meaning of this representation? That r and s cannot be simplified further. That means they don't have anything as common or anything called as common factor. But the way we have assumed it and what we have got here are two different things. In the I'll just write over here. We understood that two is a common factor of r and s, but r and s are primes because it is the most simplified form of number, correct? So are primes which have only common factor as 1. So we don't have any other common factor than 1, correct? When we assume root 2 to be r by s, what does this mean? It cannot be simplified further. Can't be simplified. That's what it meant. That means r and s are on the most simplified form. So that means their common factor cannot be more than 1. But what we have got from the proof is their common factor is 2. And why did it happen? Because of our assumption. Why did it happen? Because of our assumption. What was our assumption? That root 2 is a rational number. Therefore, our assumption, what was our assumption? That root 2 is a rational number. Rational number is not true. Is not true. Correct? Then what is true? Therefore, root 2 is an irrational number. An irrational number. Got it? So this is how we proved it. So in mathematics, there will be many such situations where you will come to know that this cannot be done in a direct way. So what do we do? That we take a contradiction, or we take some assumption which cannot be, which is exactly opposite of what we have to prove, and then in a way we found that what we assume must be not true. So in that case we say that, okay, so this is not true, then opposite of this, I mean the contradiction of this should be true. So when we say that our assumption root 2 is rational, it is rational, then when we see that it is not true, that means it is not rational. Not rational meant it is irrational. So that's how there are many different kinds of examples you can solve. We can also say in the similar way we can prove that root 3 is irrational. Okay, and there are many other kind of examples we have. Let us see one by one. Example, let me solve one more example over here. I have to show that 5 minus root 3 is irrational. Okay, again we'll assume that let's assume that 5 minus root 3 is rational. The process is same. We'll assume that it is rational, and at the end we'll figure out that it cannot be rational, so it has to be irrational. Okay, so when it is rational, it tells us, we have assumed it already that it is rational. When it is rational, we can say that 5 minus root 3 is a ratio of two integers, correct? So from this, what we are getting? We are getting 5 minus a by b equals to root 3, correct? Let's rearrange this. Let us see what we are getting. We will get 5. Wait a minute. So let us rearrange this. Let us cross multiply. We'll get 5b minus a upon b equals to root 3. Correct? Now we know that if we do this way, what will happen? Because see, a and b are integers, correct? When I multiply 5 by b, again I'm going to get integer, and a is also an integer. I'll just write over here. A and b are integers. So 5b, therefore 5b is an integer. Correct? So from this, what do we understand is 5b minus a is an integer. And we also understood that 5b minus a upon b, this will be rational number. Because this is integer, I'm in the numerator, and even b is an integer. So this is ratio of two integers. Correct? When this happens, we say that this is rational number. But have a look over here. 5b minus a upon b. What we are getting? That is equal to root 3. If this is equal to root 3 and this is equal to a rational number, then root 3 has to be rational number, which is not true. Correct? This implies root 3 is a rational number. Correct? Why? Because we got this is as rational number. This number has to be rational number. That's what we got. So this is equal to root 3. So root 3 has to be rational number, which is not true. Correct? Which is not true. So therefore, root 3 is an irrational number. So that's how we can solve many such type of questions. Let's have two more questions. So before moving further, I just want to encourage you to, if you have not subscribed our channel, please subscribe. If you have not pressed the bell icon, please press the bell icon to not to miss any notification from our side. And you can also visit our website www.letstute.com for a wide range of courses on mathematics and science. Fine, let's go to some questions. Let us solve 6 example. 6 plus root 2 is an irrational number. An irrational number. We're supposed to prove this. So how will you do that? How will you do that? We can do it by the same way. Suppose let us assume now. Assume 6 plus root 2 is a rational number. A rational number. When it is a rational number, then this can be represented by the ratio of two integers, where denominator is not 0. A and B are integers. Okay. When this happens, we can rearrange this. Okay. So what do we get from this? We get 6b minus a upon b equals to negative root 2. Correct? Now, what do you understand from this? Let us take it as 1. Okay. B, A and B are integers. Okay. Now this implies 6b is an integer, because I just multiplied 6 to b. B is an integer already. So therefore 6b minus a is an integer. Correct? So that implies 6b minus a upon b is an integer. Sorry, it is a rational number. Is a rational number. Correct? Because it is a ratio of two integers. Now look at this. If it is a rational number, it is already equal to negative 12. What does that mean? This implies negative root 2 is a rational number. Okay, so that means what? Root 2 is a rational number. But the question is it possible? Is it possible that root 2 is a rational number? It is not possible. We already know. We have proved today only. Correct? Root 2 is a irrational number. So, which is not true. Which is not true. So the assumption that tells us that root 2 is rational number cannot be true. Correct? Which is not true. So therefore, our assumption is wrong. Therefore, our assumption is not correct. Correct? So therefore, the question which we are given with is irrational number. What is the question? Therefore, 6 plus root 2 is irrational. Got it? So this is how we prove this. Every time, whenever you are asked to prove something, what you have to do? I mean, prove something in the sense, if we are asked to prove it is a rational number, we'll assume that it is rational, and we'll consider that as a ratio of two integers, and we'll rearrange and we'll get the relation where it shows that the actual irrational number is rational. That's how it shows. So where you can come into picture and say that the assumption is wrong because the result which you are getting is absolutely incorrect. So the assumption is wrong Therefore, we have to just go to the contradiction of that statement. So therefore, if we say here in this case 6 plus root 2 is not rational, that means it is irrational number. Okay, so that's how we understand how to solve this. Okay, now let's move on. Let us solve one more question for this lecture. Let us say 7 root 5 is an irrational number. Irrational number. We have to prove that 7 root 5 is irrational number. Now, first of all, we'll assume that it is rational, and then we'll come to conclusion that the assumption is wrong, correct? Let's assume assumption. What is our assumption? 7 root 5 is a rational number. That was the assumption. That's what we assumed. Okay. So therefore, 7 root 5 can be written as ratio of two numbers, correct? Where denominator is non-zero. So from this, what we understand is root 5 equals to a by 7b. What did we do? We just rearranged. We have multiplied 7 in the denominator. Okay, on the right hand side. On both the sides, we can also say that we have divided by 7, or we can say that we have transferred this 7 to the denominator of right hand side. So from this, what do we understand? A by 7b equals to root 5. In this case, a is integer, that we know. B is integer, and 7b is an integer. Okay, all three numbers are integer. So we can say that therefore a upon 7b is also, they are integers, so it is a ratio of integers. So we can say that it is a rational number. But a upon 7b is given as equals to root 5. So this implies root 5 is a rational number. But is it true? Absolutely not. It is not true, because 5 is prime and it is under the square root. So whenever such thing occurs that says prime number is under the square root, we can say that it is irrational number. So root 5 is rational number. That's what we got from the result, but it's not rational, right? Which is not true. Correct? Then what made it to be rational number? Our assumption made it look like rational number, correct? What is our assumption? Our assumption was 7 root 5 is a rational number. Therefore, we can say that therefore our assumption is not true. Our assumption is not true, and therefore 7 root 5 is an irrational number. Got it? So that's what it tells us. So whenever you are asked to prove something to be irrational number, what we are going to do is we'll assume it to be a rational, and then we'll see that what we have assumed is not true at the end. And when we understood that it is not true, then we just have to take contradiction of that. So if it is not rational, then it has to be irrational. That's what the solution is. Okay, and that's what we are asked to prove. So we have already proved it. So finally, we can say that it is irrational number. So that's how we have to, we can solve many questions. Maybe you can take some questions as homework and solve. Maybe you can take 1 by root 2 as irrational number. We have to prove this. And we can also prove where 3 plus 2 root 5 is an irrational number. You can prove this also. So there are many questions where you can go and solve and get clear with these concepts. Okay. So we are done with this topic, today's topic. And before ending, I just want to remind you again, if you're not pressed the bell icon, please press the bell icon, and so that you cannot miss any notifications from us. And please visit our website www.letstute.com for many other various wide range of courses on mathematics and science. Fine. See you next time with the new thing. Until then, take care.